Okay, so for today's lesson, I'm going to break this video up into, I believe, 4 videos so you can kind of pick and choose which one you would like or which one you need to watch. And we're going to begin with our concept on what are the rigid transformations. So let's get into the lesson. Okay, so for our learning objective, it says we will describe. Okay, so for this lesson, we're going to be describing things. You're going to be writing down a sentence or possibly 2 describing, and then the concept that we're going to be describing are the rigid transformations. Now, there's a little bit more to the whole objective. We're going to be describing the rigid transformations and giving all the details that we would need in order to do that. Now, let's go through what is a rigid transformation, or what are they, and then look at some examples. So first off, rigid, the word rigid here means that rigid is something that is hard or unchanging. And transformation, it has the prefix trans right here, meaning to change. And then form, we're changing its form. So the rigid transformations are where we change something's form, but it's something that is hard and doesn't change. Well, that means a rigid transformation simply moves things around, but does not change their actual shape or their size. So let's look at a couple of those different examples of the rigid transformations. Let's begin with the rotation. Now, a rotation is when we move a shape or we turn a shape around a center point. So here's what a rotation would look like for this triangle. You see here, I'm going to do a 90-degree rotation. That triangle is going to rotate around the origin. And very important to note, it doesn't just spin where it's at, it spins around the origin, around that center point. And it would look like this when it rotates. So that was a 90-degree rotation around the origin. And in fact, there's also a direction we would have to be able to see as well when we get to the scale. And hopefully some of you guys see that that actually was counterclockwise. So a rotation turns something. Now, if we go back to our concept, rigid transformation, it is hard, doesn't change. Well, look at the triangle before and after. The triangle didn't actually change its size. All it did was change its location and its orientation. So we moved it, but it's still the same triangle. And that's what all of the rigid transformations do. Let's look at the next rigid transformation. This one is a translation. Now, a translation, this prefix trans, the prefix trans right here in translation means to go across. So transform means to go across forms. Translation, we're going to go across location here. So translation is when I simply want to slide something around. So here I can take that triangle and just slide it sideways. I could have slided up or down or to the left, but a translation slides the shape. And something to note about translations is it doesn't change the orientation, just the location. The triangle, if I can show you this, when I look at it, I think of it as maybe pointing down. Well, it is still pointing down after a translation. So that's what I mean by its orientation doesn't change, or here we say preserves orientation, that it simply moves it by sliding it. And that's different than a rotation, where I could maybe say that it was first pointing to the left, and after the rotation counterclockwise 90 degrees, now it's pointing down. The orientation changed, right? So it turned on its side. And the last rigid transformation, the last thing we can do to move a shape and change its orientation without changing its size or the actual shape itself, is a reflection. Now, a reflection, most of us are familiar with, a reflection is when we flip something across a line of reflection. Now, if you look at a mirror, the line of reflection is the actual mirror itself. That's the plane or the line where things are flipped. So a reflection has to have a line of reflection. So look at this image being reflected across a line. Here, oops, I'm sorry. Here, the line of reflection will be the x-axis, and the triangle was reflected up across it, right? So here, if I can show you the orientation change, I'll show you in red. Here, the orientation, if I thought about it as pointing down, now that triangle is pointing up, right? So the orientation changed and the location changed. But this time, its orientation changed by flipping. So the rigid transformations, they move shapes around on the coordinate plane. Some change the orientation, reflections and rotations do, and one of them does not, a translation. It moves it without changing the orientation. So these 3 transformations make up the rigid transformations. Now, I don't want to just skip over these critical attributes or these bullet points, so let's look at them real quick. This says lines and line segments are moved without changing length. So it's important to note that when we do a rotation, translation, reflection, the lines things all stay the same. So let me highlight here in green what I'm talking about. This length right here, this vertical line, after the rotation, let me show you that that is a length of 2, right? So it's just 2 units. That length after the rotation is right here on this triangle, and notice that the length is still 2. So a rotation doesn't change length. Same thing is true on a translation. I slide it over 2, that side length is still 2 units long. Even after I flip it across a line of reflection, its length is still 2. So line segments do not change their length when we do a rotation, reflection, or translation. And let's also bring up the fact about the angles. Angles are also moved without changing the angle measure, so the angles stay the same. So the best way to show you that is with where there are right angles. So let me erase a small little portion here. Give me some room. Okay, here is the right angles. The right angles of this triangle is right here in this square corner. Well, when I turn it, it's still a right angle. It's just been turned. Its orientation has changed. Right angle, still right here in the corner, did not change the angle just because I translated it. And when I reflect it up, it is still a right angle. So angles do not change when you do any of these 3 transformations. So rigid transformations move figures without changing their size or their shape, and they do it by turning for rotation, sliding for a translation, and flipping for a rotation. Okay, the next video is going to be on how to describe a rotation, or I guess translation or reflection, depending on which one you choose to watch. All right, thanks.